Good morning everyone. Today we will start with differentiation of exponential functions. So we have two types of exponential function, differentiation of like e raised to power x and e raised to power x. First, what is the another form if we write e raised to power x and e raised to power x? Look, in your 9th class, when you are writing the exponential form like 2 raised to power 3 is equal to 8. When you write in this in your logarithmic form, so this 2 becomes the base of the log and this power move it here, and this is an example, so that we write it like if e raised to power b is equal to c, like this. So what you will write it here, in that case that formula becomes b log a, b is equal to log a and c. So that is an exponential form to change into the logarithmic form. Okay, so we are using this concept because some of the question before differentiation is very difficult to find the exponential function. So we can reduce that, we can remove the exponential form before the differentiation. So like here, if I have log x base e is equal to log e x. So according to that, if I write it here, I want to move this log on this side. So this whole term will be converted into the power of whatever base is here. So that becomes e raised to power log ex. So by default here base is e. That means if these two terms are same, so instead of writing every time e raised to power log ex, I can directly write x in place of e log ex. Similarly, if it is a log e, if this base value of log and this value that is in form of exponential form, if this value is same, so we can ignore this one and we can write directly go with x because of our exponential rule. Similarly, x is equal to e log x and e raised to power x can be written as e raised to power x log x. How? Because when you write in this way, e raised to power, because according to our log rule, log ex, this power shifted here, and e raised to power log x, because by default base is e here, so that's why we can directly write e raised to power x. But here one condition is that x should be greater than 0, e should be greater than 0, and e not equal to 1. Now we go with the differentiation of exponential form. So if we want to differentiate e raised to power x, so that is same as e raised to power x, and x further differentiation will be multiplied with this, that is 1, and log x differentiation is 1 by x, e raised to power x is e raised to power x log e. Okay, so condition is that if both are my exponential function, now question is that why we write it here log a and we don't write it here log e, because rule is same to everyone. So we write it here log e, but by default base is same. If base is same and whatever value in multiply with log is same, so that is directly equal to 1. Okay, log e, or generally we can say that log e value is equal to 1. So always we ignore this value, so it is understood that log e value is equal to 1. So we no need to write every time log e. But here base is different, so that's why we mention with log e. Similarly, if you have to differentiate log with another base at here and x, first you have to apply opening the base formula like log x by log e, then 1 by log is constant and you have to differentiate only log x, that is 1 by x. Differentiation of log is 1 by x. Similarly, differentiation of log modulus x is equal to 1 by x when no base is written. When base is written, then it will be same as 1 by x log e. So here I have some questions of exponential form. So here if I have a question y is equal to sine tan inverse e raised to power x, I want to this differentiate with respect to x. So dy by dx, first I will differentiate outer like sine. Sin x differentiation is cos, that become cos tan inverse e raised to power x and x, and whatever term inside is left, that is multiply with differentiation. Tan inverse e raised to power x. In place of x, there is e raised to power x. Now, this term now is free from differentiation. You can carry on till the end of the question. Because tan inverse e raised to power x. Now here you have to differentiate tan inverse x, and differentiation of tan inverse x is equal to 1 upon 1 plus x square. But here in place of x there is e raised to power x. So first we differentiate only the outer part. The outer part according to my rule is 1 upon 1 plus, in place of x we write e raised to power x whole square. Now whatever this inside is left, that is further differentiate and multiplied. Okay, now further my differentiation is dy by dx is equal to cos tan inverse e raised to power x upon 1 plus e raised to power x whole square. So whatever term is free from differentiation, we just carry on it at the answer, and whatever left is to differentiate, that we have to differentiate. Now e raised to power x differentiation is e raised to power x, and x further differentiation is 1. So that is my answer. Now my next question is, if y is equal to minus a, now here is a negative term, okay, minus a x square, then sine log x. So how you differentiate this one? Now differentiate with respect to x, dy by dx. So here we go with u into v method. So these are the two terms going to multiply. So this is u and this is v. So here we first keep it this one outside, e raised to power minus ax square, and I want to differentiate this one. So differentiation of sine log x. Sine is outer, log x is inner one. The sine x differentiation is cos x. In place of x there is a log x, I write as it is. And further log x differentiation, I have to do it here. Whenever last term will be, you have to differentiate until last term will be differentiated. Now here plus. Now you have to keep this term as outside, sine log x. Now I have to differentiate this first term, that first one we keep it outside, e raised to power minus ax square. Okay, so now here dy by dx is equal to, now here e raised to power minus ax square, log x differentiation is 1 by x, and cos log x by x. Now this term is now free from differentiation. Now we move to the second term, sine log x. Sine log x as it is. Now here whatever exponential is there, first you have to differentiate this exponential, then you go with differentiation of power. Okay, first e raised to power x differentiation is e raised to power x. According to that, so that will be right same as it is, minus ax square. Now further whatever this power is there, that is differentiate further, like minus ax square. Now here my term will be dy by dx is equal to e raised to power minus ax square cos log x by x, and here when you differentiate this one, this become minus 2, because minus a is constant, x square differentiation is 2, minus 2ax, then that becomes negative 2a. I write it here, I shifted constant term here, 2a, then sine log x into x, because minus 2x we get it here, minus 2ax. Now here this term as it is, e raised to power minus ax square. So in the next step also you can take e raised to power minus ax square common, and your answer will be cos log x by x minus 2ax. So your required answer will be, if you take e raised to power minus ax square common, so that will be cos log x by x, then minus 2ax sine log x. So that is my required answer. Okay, now next is, if we have different exponent terms. If we have different exponent terms, then what we will do? So y is equal to 10 raised to power 10x. We apply the formula here, e raised to power x log e. So first I will differentiate with respect to x. So I consider this whole term as x. So that first written as it is, 10x and log 10 with this. Now further you have to differentiate the power, 10 raised to power x. So that becomes 10 raised to power x log 10. Now this term is free from differentiation. Again you apply the formula here, that is 10 raised to power x then log 10. So my required answer will be 10 raised to power x log 10 whole square into 10 raised to power x. So this is my required answer. Thank you.